Today, we'll examine 7 types of water pumps and see which one is the most efficient. The first is the Archimedean pump, the world's oldest water pump. When the pump shaft rotates, the bare rod rotates around its own axis. Simultaneously, it moves along the inner surface of a bushing. With each rotation of the bare rod, the water in the bushing moves upward by a screw. As the screw rotates continuously, water is transported from a low location to a high location. This type of pump has a water flow rate of 16 milliliters per second. The most common example we see in real life is a concrete mixer truck, which has a spiral pump inside. Now let's look at the second type of water pump, the centrifugal pump. This type of pump has such a wide range of applications that we'll focus on it here. A motor drives the impeller to rotate at high speed, generating centrifugal force that forces the liquid to be ejected from its edge. This process increases the liquid's velocity, and due to the continuous impact of the liquid sheet, the liquid's energy also increases. The accelerated liquid enters the shell, where some of the liquid's velocity is converted into pressure, gradually increasing the cross-sectional area between the shell and the outlet channel. According to Bonu, the force of a constant velocity decreases, the pressure increases, and the liquid is continuously expelled. The head of a single centrifugal pump is often small, so to increase the head of the liquid in the system, engineers often connect multiple impellers in series. In this case, the liquid flows from the first impeller to the second, then from the second to the next, and so on, before finally being discharged through the outlet. It's worth noting that there are also water pumps that combine spiral and spiral pumps, with the spiral pump as the first stage and the centrifugal pump as the second, when the motor is running. Here's a question. If there's only one impeller, and there's no liquid in the pump, how do you start it? In order for water to fill the entire pump, the internal pressure must be lower than atmospheric pressure. The atmospheric pressure then pushes the water in. But then, how do we reduce the pressure inside the pump? Here's the key point. Since a typical centrifugal pump can't move air, it can only do this on its own. In this case, we have to do it ourselves. Before starting the centrifugal pump, a certain amount of water is added to the pump's outlet. This will expel the air inside and allow the pump to function properly. Returning to the model. This type of centrifugal pump pumps approximately 32 milliliters of water per second. Let's look at. But we'll discuss this later. The structure of the pump is simple, so I won't waste time explaining it here. Its maximum flow rate is 200 milliliters per second. Let's look at the fourth type of pump. This design is ingenious. The water inlet is located on the side, with an eccentric on top. As it rotates, it drives the piston below. The entire process is divided into 2 strokes. When the piston moves upward, water is drawn into the chamber through the inlet, while the outlet closes. This is the first stroke, the water intake. The second stroke is the water discharge. When the piston moves downward, the inlet closes and the outlet opens, forcing the water inside the chamber out through the outlet. This structure, doesn't it sound familiar? In fact, steam engines also work this way. Okay, but that's a side note. This type of pump has a flow rate of approximately 15 milliliters per second. Let's look at the fifth type of water wheel. The water wheel, which appeared around the end of the Eastern Han Dynasty, is a true genius. It relies on no external power. The water wheel rotates under the impact of river water. Each bucket automatically draws water as it passes the confluence. When it reaches the top of the wheel, it empties, and the water inside is automatically poured out. This method of transporting water is simple in structure, and can transport a considerable amount of water, with a flow rate of approximately 22 milliliters per second. However, its drawback is obvious. The water wheel must have flowing river water to operate. Otherwise, it won't work. Let's look at the sixth type of water wheel, the ruler wheel. Its operating principle is more complex, so we'll focus on it here. The underlying logic of the ruler wheel is that as creating a cavity, this draws in external liquid, while the volume at the other side of the liquid channel shrinks, increasing pressure and squeezing the liquid out. There's actually a different explanation. When a ruler enters the fluid space occupied by another ruler, because the liquid is incompressible, the liquid and the ruler can't occupy the same space at the same time. As a result, the liquid is mechanically squeezed out, because the rulers are constantly closing and closing. This phenomenon occurs continuously, forming a continuous flow at the outlet of the pump. The amount of discharge remains the same with each rotation, and as the shaft rotates, the pump continuously discharges liquid. These two explanations are essentially the same. It's up to you which one is easier to understand. Here, the ruler wheel pump has a flow rate of approximately 32 milliliters per second. Let's look at the last type of water pump, the dynamic pump. This is super simple. It's like squeezing a fluid-filled hose with your finger. As your finger slides forward, the fluid in the tube moves forward. The dynamic pump works on the same principle, but with a roller instead of a finger. This type of water pump has a lower flow rate, only about 5 milliliters per second. However, this pump isn't designed for high flow rates, but rather to ensure clean, contaminant-free, and precise delivery of the fluid. Okay, that's it.